We're almost to December. Look at this. Less than a month until Christmas. That's crazy. How long is Christmas break? It's usually 2 weeks. Looks like we have, so Friday the 22nd is off. And then we're off, obviously, the whole next week. And then that following week, we're off January 1st and 2nd, and we come back on Wednesday the 3rd. So it's... How did you? It's like 8 school days. And then a couple weekends in there too. So a couple weeks. Ooh. I know, right? I did not. Were you talking to me? I don't think so. I think I'm just allergic to coming to school. I needed another day off. Okie dokie. So we're not going to do any graphing today at all, like zero. Just FYI, we're going to spend a couple days now just writing equations of lines. So yeah, I'm going to start you with this. This is the second. So the one I've given you already is called slope intercept. And this one you're very familiar with, right? You know slope intercept. Remember that is y equals mx plus b. So our goal for the day is, I'm going to give you some other stuff. And our goal for the day is to write equations that look like this. Okay, so kind of as we go through this, don't lose your focus. The goal is to make answers that say stuff like y equals 2x minus 6, or y equals 3/4 of x plus 2, stuff like that. So that's going to be the goal. So having said that, I'm going to introduce you today to the second of the three. And along the way, you'll probably also meet the third. I'm not sure if I'll formally address him or not, but the second one is point slope. This one is uber mega useful. You may not appreciate its usefulness like right away. It may not be until you're a junior in high school that you go, wow, I'm really glad I know that. But point slope is nice. So point slope is going to look a little bit confusing to you at first, just so you know, but it's really actually quite nice. So this lesson will take a little time. So it'll be a little work time today, a bunch of work time tomorrow. But point slope is going to be kind of where we start. And then we're going to convert our point slopes, because you guys are so good at like distribution and solving equations, that going from point slope into slope intercept is going to be what we do. So we're going to start with yellow box. And the goal for the day is to convert yellow box into purple box. Got it? Okay, so let's first talk about this new equation, this one in the yellow box. It can look a little bit confusing. I think you know this, but I guess we probably should address it formally. What is m? Sorry to hit you with all these math questions right after Thanksgiving break, but you know what m is. It's the slope, right? It's just universally what we accept as the slope. So whenever we see m, we know we're going to put the slope in place of m. All right? And I kind of have that arrow pointed the wrong way, because technically the slope's going to go up in place of m, but either way, you get the idea. And then these are the coordinates of the point that we're going to be given. If you don't know the coordinates of a point, you can't write the equation of a line. Like, you have to know something physically about a point that the line goes through. If you don't have that, you're kind of out of luck. So generally today, we're going to, whether it's directly or not, you're going to be given a slope and a point, and then you're going to use that information and plug it in and make it look like the gold box. And then you're going to take the gold box and make it look like the purple box. Quite an adventure. So let's get started. So make sure you wrote this down because I'm going to scroll up now. So that point slope is going to be our foot in the door. It won't be the last time you hear me say that. So here we go. So let's say I told you I was thinking of a line that passes through the point 4, 7 and has a slope of 2. Looking at that point slope box, what we're going to do is we're going to replace the 3 things that we identified, the M, and then the X1 and the Y1, we're going to replace those with numbers. So I'm going to write it again up here for you. So here's the point slope template. So Y minus Y coordinate equals M times X minus X coordinate. So I'm going to underline the important things. In fact, I'm even going to color code them for you. So M right here is going to be my slope. Y sub 1 right here is going to be my Y coordinate. And X sub 1 is going to be my X coordinate. So I know you don't probably take notes in color, but try to find some way to associate those 3 things with the places where they're going to go. Just so you know, because I think perspective is always important, what I'm about to ask you to do, if you can get past the newness of it, is monster mega easy, like off the charts easy. Okay, so we're going to copy that red equation, but whenever we get to something that's underlined, we're going to swap it out with a number. So the very first thing says Y minus. And what are we going to put in place of Y sub 1? 7. And then we're going to put equals. And then we encounter the slope, the M. And what are we going to put in place of M? 2. Very good. And then we're going to open a set of parentheses and put X minus. And what are we going to put in place of X sub 1? 4. Very good. So what you have right here is a completed point slope equation. Now, I decided today that we're not just going to stop there. Let's go ahead and get this all done at once. And so once we have that, that's our foot in the door. We have an equation, but now we have to take it and modify it to make it look like I said we were going to at the beginning of the lesson. So if you go back up here, remember, we have yellow box now, and we want to make it look like purple box. So we want to convert this equation, this white equation, into something better. What do you suppose we could slash should slash have to do first? Distribute, for sure. Let's take the slope and distribute it through. So we're going to leave the left side as Y minus 7. And if you distribute the 2 on the right, what do you get? 2x. Beautiful. And as you can see, we're one step away now from what we identified as our objective. The objective is to get it to say y equals mx plus b. So what's the one number that's out of place? The 7. The minus 7 is like, I'm not supposed to be here. Like, you're trying to get this to say y equals. So get rid of me. So why don't we take this minus 7 and add it to the other side? So we just transport it over there like this. And I'm going to show my work. I won't always show this, but by adding 7 to both sides like this, I get a completed product. These 7s are going to cancel, and I'm left with y equals 2x minus 1. And this is the goal for the day. That's our answer. So when given a point and a slope, we plug them into their happy little homes, their 3 little spots, x1, m, y1, and then we distribute, move stuff around, and presto, done. Kind of, sort of okay? Not bad? All right, let's practice again. This time, I'm thinking of a line that goes through the point -3, 5, and has a slope of -4. All right, let's do it. So we're going to begin by writing our point slope, which is y minus what? 5. Very good. Remember that the y coordinate will always go over there after y minus the given y coordinate. Equals. And what goes after the equal sign? Good job. Now watch out. You're about to potentially get tripped up here. Times, and then in parentheses, x minus what? It is a plus sign. Very good. This minus, I'm going to point to it with a yellow arrow. This minus is always here. But when right after it, I'm going to put a negative number. As you know, a minus and a negative come together to make a plus sign. So we're actually going to put plus 3 like this. Still good? All right. Now it's time to distribute and convert. So I'm going to leave the left side as y minus 5. What's my right side going to say? Minus 12? It's okay. It's the first Monday after Thanksgiving break. We're going to have some brain farts. I'm just waiting for my first one. Knock on wood. Haven't had one yet. It's coming up. And the last step, let's move that 5. So we're going to get y equals negative 4x. And now don't say something crazy like minus 17. Remember, when we add that 5, what do we get? Minus 7. Very good. Finished product right there. Still good? All right, let's go again. This time, we're going to go through the point, negative 1, negative 4, and our slope is going to be 1/2. If you haven't seen it yet, the first step is pretty cake, right? Like you're literally just popping numbers into a happy little formula, a little template. So left side, here we go, is going to say y what? Plus 4. Very good. Equals 1/2 times the quantity of. Good job. So let me pause here. It's important that you answer this honestly. Anyone have any questions about going from here to here? Just popping numbers in, right? All right, let's do this. Now, ordinarily, since you're awesome, you guys might say something like, let's kill the fractions. I wouldn't advise that because then you're going to have a number in front of the y that you're going to have to get rid of later. So let's just roll up our sleeves and tough it out, and let's distribute like we always do. We can handle this. Like we're in high school, we can handle a little fraction distribution. So we got to do that distribution and that. So copy down the left side, y plus 4 equals, what's 1/2 times x? Good. And what's 1/2 times 1? Very good. Now watch out. This step will not be enjoyable for some of us, maybe. I don't know. If your basic skills are a little lacking, you might not like this step. So we're going to write y equals. You're not going to modify the thing I'm circling in red. That part does not get touched, okay? That is off limits. It's done. We know the slope. We're good to go. So we got y equals 1/2 of x. But if you take away 4, so if you had half a dollar, like 50 cents, and you took away 4, what would you have? Negative 3.5. Very good. And that is our final answer. Got it? Let me pause this real quick, change my attendance. So things change now. I'm sorry to have to ask you questions like this, but it's kind of part of the deal. I need you to have a certain thought. So if you hadn't already noticed it, I'm forced to ask, what's different? There's no slope. And that's a big deal. You're going to quickly come to appreciate that if you don't have a slope, that's always job one, is to say, I got to get me a slope. So we can do this, though. We can find the slope, right? We've practiced this. You did that whole worksheet with the cheesy dad jokes on it where we just practiced finding slope. So let's do this. Let's find the slope. So when you're not given the slope, it's important that you go and find it yourself. So this is where we have to use our little nice. Good. So what's that going to look like when I go to find the slope? What's my top subtraction problem going to say? 8 minus 6 over. And what's my bottom subtraction problem going to say? 2 minus negative 2, or 2 plus 2. Very good. Let's reduce. Let's simplify. Let's do a little bit of basic little kiddie math. What's 8 minus 6? And what is 2 plus 2? And what is 2/4 reduced to? Good. So we can now say that the slope is a half. Now, at this point in time, what I'm going to do is I'm going to erase my work and let's focus. If you think about it now, we're right back where we were in the last problems. Really, the last problems, we were given a slope and we were given a point and we plugged them in their happy little homes, right? The only quandary here that I would ask if I were sitting in my own class would be, but there's 2 points. Here comes a question for you. Which one should I use? Does it matter? It doesn't matter. So like if Mila did this problem and she did it using this point, that's okay. And then if Jesse did this problem and he did it using this point, that also is okay. And you might think like, aren't they going to get different answers? Nope. If neither one of them messes up, it's going to work. So let's do the red point first. So we're using the slope down here. That's this guy. And we're going to use the red point. Clear? What would my point slope equation say if I use the red point? Equals, in parentheses. Nice. Now, before we press on, I'm going to head over and do the yellow point also. So let's say, again, you got 2 students sitting 10 feet away from each other. One uses the red point and the other uses the yellow point. Now, these answers are going to look different for a minute or so. That's okay. So let's do Jesse's point, the yellow point. What's his answer going to say? Great. So get those written down, get all the stuff, make sure you have what you need, because I'm going to scroll the screen now way up so that all I have are the red and the yellow. So here we go. Remember, these are not final answers. These are just works in progress. And so right now, Mila's answer and Jesse's answer, they look like they're not even in the same neighborhood as each other. Let's work them out. So let's do the red one first. Help me with distribution. What's 1/2 times x? Well, that's easy. What's 1/2 times 2? Okay, let's head over to the yellow one and let's do Jesse's distribution. So we have y minus 8 equals, obviously, 1/2 of x. And again, take that second distribution. What's 1/2 times the negative 2? Minus 1. Very good. All right, let's finish it off. Let's go back to Mila's side, the red side. So Mila picked the red point. And if I move the 6 by adding 6 across like this, what's her final answer going to say? Awesome. So this is Mila's final answer. And Jesse, sitting 10 feet away, is over here with the yellow one, working his magic, and he gets y equals, same thing, take your -8, but add 8 to both sides across like this. What do you get? 1/2 of x plus 7. The moral of the story, that's a very important example for you guys. The moral of that story is that, like I said, it doesn't matter which point you pick when you've got a couple to choose from, as long as you don't make a boo-boo. It's going to come out in the end. You still with me? All right, a couple more and then it's work time. So here we go. Let's do through the point -56, 109. Slope is 0. You should have this separated somehow in your notes. Do something later on. If you use colors, go home, highlight this, and mark that this is a unique situation. Make a mark that I'm not going to do this problem like I did the others. This is not a math problem. If anyone is still awake and listening, if you're not, wake up, listen. This is not a math problem. This is just a do I think straight problem. What kind of line has a slope of 0? Good guess, but no, that's what a lot of people would have said. Horizontal. So as soon as I see that the slope is 0, then I know that I'm working with a horizontal line. And then I have to go back into my dusty old, it's Thanksgiving break, I'm just coming back, the files gathered a little dust in the cabinet. How do you write the equation of a horizontal line? What do all horizontal line equations look like? Anyone remember this one? I know what the line looks like, but do you remember what the equations look like? Y equals whatever it is, exactly. Now, the thing about it is it's not y equals mx plus b. Remember, horizontal lines are just y equals a number. And, sorry to have to ask you such a stupid question, but up here, which of these is the y coordinate of that point? Then there's your answer. Done. As soon as I identify it as a horizontal line, then I go, wait a second, this isn't really a math problem. I don't have to distribute and move stuff around. I just have to understand that a horizontal equation is just y equals some number, right? Piece of cake. So watch out for those. Those are lovely. And you might know where I'm going with this, but let's do another example. This time, let's go through the point -84, -45, and the slope is undefined. Again, it's recognition. It's going back in the dusty old file cabinet and saying, ooh, okay, again, this is not a plug numbers in and distribute kind of thing. This is a weird one. What kind of a line has an undefined slope? A vertical line. And again, I go back either in my notes or in my notes in my brain, my memory. How do you write the equation of a vertical line? X equals some number. And I'm, again, sorry to insult your intelligence, but up here in what I'm underlining, which of those is the X of that point? Then every point on that line has the same X. That's what makes a line vertical. If all your X's are the same, you're vertical. So the answer is X equals -84. So if one point on the line is left 84, then every point on the line is left 84. That's what makes a line vertical. What do you think? Can you handle it? All right. So your assignment is on Canvas. It's a PDF. It's back to the normal. So if you go into today's Canvas, which I honestly am not sure I've published it yet, but I will here in a moment once I get this video kind of converting. And then same thing, just open the PDF and do the problems on your own paper, if you'd be so kind. I'm going to leave the recording going because there's probably going to be questions that I forgot to address. There was a request to go over problem number 3. So let's do it. So again, this is problem number 3. So this is one that we kind of started the lesson with. So this is where we're given a slope and a point. So we're going to dive right in and start writing our point slope equation. So what's that going to say, Addie? What's it going to say when we start it? It would be y minus the one I just circled, because that's the y. So what, y minus -3, right? We should do +3. Very good. And then after that? Good job. And then a parenthesis and an x minus 3. So to this point, absolutely gorgeous. Perfect execution. So you've got your point slope equation, and now it's time to do the distribution and simplify, or not simplifying, but the converting. So when we take this -5/3 and we do the yellow arrow, what do we get? What? Good job. And when we do the purple arrow, I assume most people, when they ask, can we go over this problem, they're going to ask just because of this step right here. So when you have a fraction and a whole number, you have options. Sometimes you can use the little hook trick, but the safest option, the one that's always going to work for you, is just write it out like this, dude. So you just got your -5/3 times -3, but we want to put the -3 over 1, because you always want fractions to play with other fractions, right? So do you notice anything in that multiplication? Hey, boys, can I have just a minute? Do you mind? I'm just trying to talk to someone that's right behind you. So give me, you're fine. Just give me a moment. I know you're working together, but what happens in that multiplication problem? Right, I agree with that. So we would agree then that these negatives are going to cancel. Good. What else do you see? Right. And to get there a little quicker, Addie, you could have actually just crossed out those 3s. They're just going to cancel each other. But the way you did it is fine also. Either way, you and I are going to get to the same place, and that is +5. So are you with me so far? All right. And now there's one more thing to do, and that's to get that pesky +3 out of there. How do we do that? So what are we going to have on the other side? And don't say 8. Yeah. So it's like a -3, right? But it's going to go with the 5. So you already have 5, and you take away 3. What do you get? So what's our final answer? -5/3 x. And that is it. That all makes sense? Beautiful. What do we know in problem 2? What are we given? Like what does the problem say? 1 -5? 1 5, okay. So right away, you recognize that we don't have the slope, right? So we have to do that first. So what's our little slope thing going to look like? Yep. So what's that going to look like mathy wise? What's that going to say? Good job. And then on the bottom, what's it going to say? Okay, good job. So you've gotten us off to a good start. And now we just need to make sure we don't mess up any basic math. These are the things that happen. Like I say 2 minus 5, and in a perfect world, no one would ever say something stupid like 3. So I'm telling you, don't say 3. What is 2 minus 5? Good job. So we have -3 for the top of our slopey guy. And then on bottom, what's 0 minus 1? Nope. Yep. So let's clean this up a little bit. First off, it's a negative over a negative. And what's 3 over 1 really the same as? Okay, good. So we can now say that the slope is 3. You agree? Okay, so I'm going to erase my work now. And now you're in a position where you have to pick, and we had this conversation earlier, like when I did the Mila Jesse, the red-yellow problem, like which point you pick is completely up to you. Which one do you want to use? Okay, let's do 1 and 5. So the way I do this sometimes, just kind of for effect, is I do this. Like once I commit to one of the points, and you probably shouldn't do that because I, then I might not be able to read it. But like the point is that now we are focused just on the 1 and the 5. So what is our point slope equation, like our first answer, going to say? Absolutely gorgeous so far. Okay. And you're almost there, dude. So now you just have to distribute and then move. So let's do one thing at a time. So next step is just copy down the y minus 5. What's this right side going to say? Nope. Yep. And then, of course, there's one thing left to do, and it's to take this minus 5 and add it to the other side. So what do we get? -3 is already there, plus 5. The number 8 is nothing to do with this. The temperature outside is -3 degrees. And it goes up 5. What's the new temperature? Look at your number line up here. Start at -3 and then add 5. You added 6. That's it. And as is often the case, your issues in that problem were not the algebra, that's the little things. And with any math problem, there's one math problem, but within that there's like 10 little math problems, and they all have to go right. Everyone, right? Make sense? Yeah. Okay.